Hello students, welcome to mathematics class. Students, this is part 14 of the chapter linear equations in one variable. In this part 14, we will discuss example number 10 and 11, which are application related of this linear equations, and then we will solve some of the questions from the exercise 2.2. Coming to the question number 10. Question number 10 is the difference between two whole numbers is 66. The ratio of two numbers is 2:5. What are the numbers? The moment you see ratio, always assume let the ratio constant. Let the ratio constant is x. Therefore, if the ratio constant is x, we will have numbers generated. Therefore, the whole numbers are 5x and 2x. So, the moment you know whole numbers from the help of ratio constant x and the ratio, now we can use this condition. The difference between two whole numbers amongst these 5x and 2x, you know, difference is done by subtracting, which is equals to 66, that is 3x equals to 66 and x equals to 22. The moment you know what is x value, by substituting here, therefore, the whole numbers are 22 5s are 110 and 22 2s are 44. So, this is how we solve this example number 2. Now, coming to the question number 11, that is example number 11. Deveshi has a total of rupees 590 as currency notes in the denomination of rupees 50, 20 and 10 rupees, and they gave you the ratio of the number of rupees 10 notes and number of 20 rupees notes as 3:5, and even they gave you the total number of notes as 25. Now, you are asked to find how many notes of each denomination that she has. So, for this same, since we have got a ratio, we will assume, let us assume that ratio constant, the ratio constant be, so I am assuming the ratio constant as x. So, from this ratio constant, now we have got 3x giving number of notes of rupees 50 as 3x, number of notes of rupees 20 as 5x, and since the total number of notes is total number of notes, she has a total of 25 notes. That means number of the notes of rupees 10 will be from the 25. If you take away the total number of the notes in 50 and number of notes in the form of 20. So together they give 3x plus 5x, 8x. If I take away that from 25, it gives me how many notes are of 20, 10 rupees are there. So we use this information in finding number of notes of rupees 10. Now, by the total money with her is rupees 590. Therefore, money in the denomination of rupees 50 plus money in the form of rupees 20, money in the form of rupees 10 to be added. Money in the form of denomination of rupees 50 and rupees 20, and in the rupees 10 put together is rupees 590. Now coming to this one, we have 50 rupee notes in 3x in number. If I multiply, I will get the money. And 20 rupee notes, there are 5x in number. If I multiply this 2, I will get the money in the form of rupees 20. And I have rupees 10, 25 minus 8x number of them are there. If I multiply, I will get the money in the form of rupees 10, which is put together equals to rupees 590. So now we shall multiply them. 50 3s are 150 x plus 25s are 100x plus this 10 will be distributed among this 25 minus 8x as a distributive property, multiplication over subtraction. So we have 10 25s are 250, 10 minus this plus over minus gives you minus here, 10 8s are 80x equals to 590. Here the like terms are 150x, 100x and 80x, and this 150x and 100x are to be added, that is 250x, and this 80x to be subtracted from it, plus 250 equals to 590. Now this 250x minus 80x is 170x, plus 250 if it is sent that side, it gets subtrahend. So 590 minus 250 gives 340, which is equals to 170 times of x. Therefore x equal to, this 170 is a multiplicand. If it goes that side, it does division, it becomes divisor. So therefore x equal to 2, we have the ratio constant value found. Now from this ratio constant we will find number of notes of rupees 50. Therefore, the number of rupees 50 notes, 3 2s are 6 50 rupee notes are there. The number of rupees 20 notes, 2 5s are 10 10 20 rupee notes are there, and the number of rupees 10 notes, from 25 I have to subtract 8x, 8 2s are 16, 25 minus 16 gives you 9. So, this is the answer. Now, coming to the exercise 2.2, we shall solve few questions of exercise 2.2 for today's session. First question is, if you subtract half from a number which we don't know and multiply the result by half, you get 1/8. What is that number? See children, always inside of these questions we need to assume that number are unknown. Let the number be, I took y now. So, let the number be y, and half subtracted from that gives you y minus half, and it is multiplied by half gives you 1/8. This is the formation of equation. Now, here y minus half into half equals to 1/8. Multiplication over subtraction can be done in one way by distributing. So, y into half minus half into half equals to 1/8. This y into half is y by 2 minus 1/2 into 1/2 is 1/4 equals to 1/8. This subtrahend, if it comes this side, it becomes addend. So, 1/8 plus 1/4. Now, y by 2 equals to, sum of this LCM is 8, 1 plus 2. So, y by 2 equals to 3/8. Now, this 2 is a divisor of y. If it comes this side, it becomes multiplicand. So, 2 1s are 2 4s are, therefore, y equals to 3/4. So, what is that number we found? This is one method we can do. There is another method of solving the same equation. Another method is y minus half into half equals to 1/8. Here, this half is a multiplicand of this y minus half. This half, if it comes this side, transposed, it becomes the reciprocal. Reciprocal of half is 2/1. Now, 2 1s are 2 4s are, y minus 1/2 equals to 1/4. So, 1 1s are 1, 4 1s are 4. This half, if it is transposed this side, it is subtrahend here. In right hand side, it becomes addend. So, 1/4 plus half, 1/4 plus half is 3/4. So, this is how also we can solve same linear equation. Now, coming to the next question, question number 2. The perimeter of a rectangular swimming pool is 154 meter. So, we have a rectangle wherein which the length is 2 meter more than twice its breadth. So, in this rectangle, if I assume breadth as, let us say, b, then length is 2 times b plus 2, because it is 2 more than twice breadth. So, that is going to be the length of that rectangle. Now, we are given perimeter. So, with this assumption, let us assume that the breadth of the pool as b, therefore, length equals to 2 times b plus 2. You know what is length and what is breadth, and perimeter of the rectangular it is rectangular pool is 154 meter. It is nothing but 2 times of L plus B equals to 154 meter. You know, 2 times of L is 2B plus 2 plus B equals to 154. By adding this inside bracket, B plus 2B is 3B, both are like terms. 3B plus 2 into 2 equals to 154, and 2 is going to multiplication distributed over addition. So, 2 3s are 6, it is B, 6 times B plus 2 2s are 4 equals to 154. Now, this plus 4, if it comes this side, it is subtrahend. 154 minus 4 gives you 150. 6 times B is 150, and B equals to, if here 6 is multiplying in the right hand side, it divides. So, B equals to 25. So, the moment I go the breadth, conclusion will be, therefore, the length and breadth of the pool are, so breadth is known 25, so length will be 2 25s are 50, 50 plus 2 52 meter and 25 meter respectively. So, this is the conclusion. Now, coming to the question number 3. In the question number 3, the base of an isosceles triangle. In an isosceles triangle, we have these two sides being equal. Let us say those two sides are xx, and base is given as, this is base. So, BC is base, AB equal to AC is equal sides, and that base BC is 4 by 3 centimeter. So, we will start assuming, let the equal sides of an isosceles triangle are let the equal sides, let the measure of equal sides, we can say Therefore, perimeter is 4 integer 15 by centimeter, which is nothing but 62 by 15 centimeter, is x plus 4 by 3. X plus x is 2x plus 4 by 3 equals to 62 by 15, and I just mixed fraction, I made it as improper fraction. 4 by 3 is addend, if it comes this side it becomes subtrahend. So, 62 by 15 minus 4 by 3, continuing further. So, 2x equals to 62 by 15 minus 4 by 3, LCM is 15, 62 minus 3 in 15 for 5, so 5 4s are 20, gives 42 by 15 is 2 times x. This 2 is multiplicand, if it goes that side it does the division, so it becomes 1 by 2, 2 ones are 2 21s are, so x value is 21 by 15 or 1 integer 6 by 15 centimeter. So, write the conclusion. Therefore, the length of equal sides is 1 integer 6 upon 15 centimeter. So, this is how we solve this question. So, with this I will wind up this session. From the question number 4 onwards we will solve in our next session. Till then, take care of yourself. Jai Hind. Thank you.